Hey everybody, it is me back again with another video. So recently I posted to Facebook about how I edited Wikipedia, inserted some mathematical equations into the page about gauge, which is a bore diameter of shotguns and some other guns. And I'm going to explain the reasoning behind my formula. I did post the full explanation on the Wikipedia page, which again is gauge, parenthesis, bore diameter, end parenthesis. But I'm going to explain it in this video, hopefully to make it a bit clearer, if anybody's wondering. So first of all, very quickly, I'm going to explain why I came up with this. It overall took me about 6 months to do, not like I was working on it for the full 6 months. It only took me like maybe 4 or 5 hours to go through this whole thing. But I kind of pondered on it for 6 months, you know. Ended it today, started it 6 months ago. So the why I did it is that you have these 3 formulas here that were previously posted on Wikipedia, or they're still there, but these were like you could say the original ones. This one here is to find diameter. As you see it's the cube root of 7,000 divided by 1501.339 n. So even though this formula works, there's a problem with it, is that it doesn't give any kind of good explanation. The only explanation it gives is that there's 7,000 grains in a pound, I believe, and it doesn't say anywhere where this 1501.339 comes from. Like, it doesn't give any explanation at all. So if you wanted to take this to 7 significant figures, great, but if you wanted to either get a more accurate answer or learn about how it was made, there's no way to do that. Similarly with these two, this one is a bit more clear. It shows 6 and pi, and then you have these two numbers that you can look up. This is the number of grams in a pound, it's 453, and then this one, 11.3, is the density of lead. But again, this doesn't have an good explanation, and also gives the result in centimeters of a bore, not inches, which is how it's usually measured. For example, like a 50 caliber rifle is 0.50 inches wide, the barrel. And then it also gives this equation as being equivalent to 4.2416 centimeters times 1 over the cube root of n. Again, it doesn't come with an explanation and no way to expand it or show how this was simplified down to this. So that's why I came up with this equation. Yes, I know it's big, but it's quite simple, relatively simple, pretty easy to understand. So I'm going to first explain how I came up with this. So if you don't know about gauge is the number of balls that will fit. Excuse me, let me start over. So imagine you have 10 balls. They are perfect spheres made out of pure lead, and they're all the same size. Each one of those balls will have the diameter of a 10 gauge shotgun because there's 10 balls. If you have 20 balls that are, again, same size, perfect sphere, pure lead, then they'll be the same size as the 20 gauge shotgun. That's just how it's measured. And the important thing is that they all weigh 1 pound combined. So the first thing we have here is this number is 453.5937, which is the number of grams in a pound, because whatever our gauge number is, that's how many balls are going to fit in a pound. So we divide it by the gauge number, and that gives us, because say there's 10 balls in a pound, then each ball is going to weigh 1/10 of a pound. So then this number that we get in the parentheses after we do these two things is going to be the weight in grams, or the mass in grams, of each one of our hypothetical balls. So the next part is this 3 and 4 pi. So where does this come from? So as a lot of you probably know, the equation 4/3 pi times r cubed gives you the volume of a sphere. So if you wanted to find the radius of this, you have to take the volume over here. So you divide both sides by r3. So you get 4. An alternate way of writing 4/3 is 4 pi r3 over 3, which is what I'm going to do here. 4 pi over 3, and then we divide both sides by r3, so we don't have r3 over here anymore. We have v divided by r cubed over here. Then what we do is we take v down here, so we have 3v, and cross that out up there. We have a 1 here because that's the multiplicative identity. Then what we can do, because this r3 is on the bottom, we want it on the top, so we have 3 times the volume divided by 4 pi equals the radius cubed. And we're going to work with this radius cubed to get the diameter, which the first step in that is taking out this cubed. So if we take the cube root of this, like this, and cross that out, then we get 3 times the volume divided by 4 pi equals r. So what's the volume? So if we find the if we assume that the density is 1 gram per milliliter, we can just use the weight in grams as the volume, which is what I have here. This is why it's 3 times this volume, 4 pi. But the density is not 1 gram per millimeter per lead, because they're solid lead balls. So what we do here is divide all this by 11.34, which is still inside the cube root, and then that we end up with the radius there. So you'll notice here that there's 2 main other things here, or there's 3 changes from this equation to this equation. We have this additional divided by 1.27. Actually, take that out. I miswrote that. That is not to be divided by 1.27, because that's where this thing comes in. So we have, that's a silly mistake. We have density instead of radius, and we have this additional fraction here instead of just this problem. So what we do here, so this so far is pretty good. It gives us the radius, but the thing is, because we calculated this in grams with a density of grams per milliliter or grams per centimeter cubed, it's going to give us the radius in centimeters, which is what I didn't like about this here. And also, it doesn't even give us the diameter, it's the radius. So what in the world? So what we do here is we simply multiply by 2 to get the diameter in centimeters, and to convert centimeters to inches, you divide by 2.54, which we can put a division sign in here, but it's the same as just doing this. So this is our equation here, or it might be simpler to look at this one, because I didn't write in our density and numerical measurement there, our gauge measurement. So this is our equation, and we can simplify it down to this equation here. Well, how do we do that? So it's pretty simple. The reason why that 1.27 was there is because I wasn't really thinking when I wrote this out, because this fraction here actually reduces to 1 over 1.27. And then something else kind of funny here. So this entire top part here gets divided by 11.34. So what we can do instead is multiply it by the reciprocal of 11.34. So we have a giant cube root sign here, and then we have 3 times, I'm just going to shorten this to 453 divided by n over 4 pi. And then we multiply it by the reciprocal of 11.34, which is just 1 over 11.34. Now we have another reciprocal here, which is 4 pi, or it's not another reciprocal, it's just on the bottom of the fraction. So instead of dividing this part by 4 pi, we can multiply that by its reciprocal also, which is, you guessed it, it's 1 over 4 pi. Extend our radical here, and cross out 4 pi. So, and another cool thing is that you can take this, if you take an I can't remember if they teach this in Algebra 1 or Algebra 2, but this radical sign, you can just distribute it over all these. We're not going to distribute it over the 1 divided by 1.27, because was never there, but all these other things you can. So we have cube root of 3 times the cube root of 453 divided by n, which is the same as the cube root of 453 with those extra single decimals, times the cube root of 1 divided by n. Write these cubes in here, times cube root of 1 divided by 11.34 times the cube root of 1 over 4 pi. Now if you remember this exponent lessons, you're looking, okay, we got all these reciprocals here, which look dumb and they're hard to write. Reciprocals, as you may remember if you learned about exponents, this 1 over n is the same as 1 over n to the 1 power. When you work with exponents, you can flip fractions, and just make the exponents negative. So this n to the 1 here, we can move this to the top and get n to the negative 1 over 1 to the negative 1. But 1 to the negative 1 is just 1. So this is n to the negative 1 right there. And I'm going to rewrite all these other ones here. Go ahead and write that n to the negative 1 again so it's bigger. N to the negative 1. Cube root of 11.34 to the negative 1. And the cube root of 4 pi to the negative 1. In fact, this can also be written as cube root of 4 to the negative 1 and the cube root of pi to the negative 1. It's the same thing. So then, in addition, in similar classes you've learned that cube roots, or these roots, are the same as, for example, a square root or a second root is the same as having an exponent of 1 over 2. Cube root is like 1 over 3. Fourth root is like 1 over 4, etc. So what we can do is take this negative 1 and put it on top of our fraction for an exponent, and then the root is what goes on the bottom. So we can do this with all of these again. Four to the negative 1/3, and then pi to the negative 1/3. And we can do, even though these obviously aren't to the negative 1 inside of the thing, we can still take them to the 1/3 power because they're in a third root box. In a third root. There we go. And also this last reciprocal, the 1 over 1.27, is simply 1.27 to the negative first power. So you notice we have a bunch of numbers here except for this n that doesn't have any of his friends here. He's the only variable. All these other ones are constants, and look at that. They are all multipliable together. Forgot to add in some multiplication signs here, but this is just a line of times. Line of multiplication. This times this times this times this, etc. So what we can do is take all these times each other times n, and that's how you get this equation. Obviously you have to use the exponents first. So grab my calculator. Like this, 1 divided by 1.27 is going to be like 0.78 with some decimals, etc. But after you work out all these exponents and then multiply all those together, you get the number 1.67, etc., 051437 here. And then you're left with n to the negative 1/3, which you can't simplify, but it's still multiplied to that, so you have n to the negative 1/3. So that's how you go from this equation to this little teeny equation. Looks really nice there. And this was confusing. I don't think it was, but all these are actually equal to d. And this is the d. All these d's here. This is an n, but all these d's have d with a subscript n. I'm not really sure why the n needs to be there, or if it needs to be there at all, but I'm writing it that way. It's the number that is the diameter. So that's just the same as the diameter. So, and how did I get this one here? You have n, this number, 4.6617922232, times d to the negative third. So, what you can do here is take all these numbers here and divide them by d. Or divide them by on both sides of the equation, which means that they'll be gone from this side and be on the bottom half of a giant fraction that's under d. Another thing, because if you've noticed they're all divided by 3, all the exponents except for this one have a 3 as the denominator. So you can take every single one of these numbers and this d on the other side, the entire equation, and take it to the third power to get rid of all these negative 3, or all the 3 denominator on the on the fractions on the exponents. And then this negative 1 will become a negative 3, and the d will become a 3, or d to the 3. And then this n will stay negative 1 here. So your equation is going to end up looking like this. You have d to the 3, the giant box there, 1.27 to the negative 3, times 3 to the negative 1, or no, excuse me, 3 to the positive 1, times 453 to the positive 1, which we don't actually have to write a positive 1 there, because it's just times 1 is what that means. Then we have n we're going to keep over here, so we have a variable and it's not equal to 0. Then we have 11.34 to the negative 1 power times 4 to the negative 1 power times pi to the negative 1 power equals n to the negative 1 power. And this is going to be a bit easier to explain, because remember that all these to the negative 1 power is basically the reciprocal. So we can rewrite this n to the negative 1 power as 1 over n, like it was up here somewhere. There. Or there before I crossed it out. And this will be a bit easier to see. And then also what we can do is this d to the positive 3 is on top, and if we bring it to the bottom, it'll just be d to the negative 3 and be multiplied by all those, which will leave a 1 up here. So you notice that there's 1 on top of both equations and tons of stuff on the bottom. So what we can do is just flip these equations over so that the 1 is on the bottom and there's nothing on the top. So, and if there's if you draw a line here with 1 on the bottom, you know, then that can't, the 1 doesn't need to be there. Anything divided by 1 is itself. So we can erase these lines here, and then this is our final equation. We have n, which is on the other side here, equals this number times 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 n to the negative 3 power. And when you when you simplify all the exponents and then multiply all these together, you get 4.66179222 times d to the negative 3 equals n. So that's how you get these two equations here. And then if you wanted to get one that's much more specific and not rounded to, I think this is 8 significant figures or 9 significant figures, then you can use this equation here, or these equations that I've lined out, to calculate to the best of what your calculator uses the equation, because all these are third roots, which are irrational, like they go on forever. So you could calculate this to basically an unlimited amount of significant figures. It doesn't, like this number string here is not going to end. So that's why I'm outlining this, and like I said, it's in the Wikipedia article gauge, parenthesis, bore diameter, end parenthesis. Explains about shotgun bores, and I did list an explanation of all this in there if you want to read through that, if you didn't catch something. I hope this was clear enough and it made sense. Obviously I can't promise that. If you're math retarded, not feeling the best on your math, you're probably going to be like, what just happened in front of my eyes? I did not follow any of it. If math is more your strong suit, you'll hopefully get what I'm talking about. Hopefully you can see the numbers that I'm writing here, because I know it's a bit small. Well, like I said, I did post a explanation in the Wikipedia page, and hopefully that if you didn't catch this, then you can read through that. So thanks for watching, everybody. I've been working on this for a while, like I said, and I wanted to make sure and post a useful explanation to it, an accompaniment to my Wikipedia article. So, see you later.